All right, so SIne Rule, what is it? Well, I'm going to just derive it for you quickly because it's actually fairly straightforward. Let's have a look at this triangle here, and this is a non-right angled triangle. In other words, there's no right angle here, there's no right angle here, there's no right angle here. So therefore, we cannot use SOHCAHTOA because SOHCAHTOA is only for right angled triangles. Right angled triangles. You can't use it. The same thing. Can you use Pythag with a non-right angled triangle? No, you can't. So good old Pythag, he won't work either. Now, let's just, this is really basic trigonometry though. I'm going to look at the triangle on the left here. And I'm going to look at the triangle on the right. Because when I do split this one up, I can say that this is a right angle because this is a vertical line. Let's have a look at triangle 1. Looking at triangle 1. So, when we look at triangle 1, I'm going to use SOHCAHTOA with that triangle because it is a right angled triangle now. What can you tell me? We've got this point, I guess, P, which is, this point P is the point in which it intersects this line segment BA. So P is this point here. Now how would I work out, I have P and I also have, I guess A if you like, have a length here. What can you tell me about this length here, BP? How would I work out BP? What's the length of BP? I'm not sure. How do we work out the length of BP? Is there any way we can work that out? No?
Is that a...
Huh?
Yeah, one.
Oh, right.
I'm just going to pause it here and get you to think about it. So if you're watching this at home, I'd like you to think about how can I work out BP? I want to work out using SOHCAHTOA in triangle 1 and 2, and we're going to actually define this SIne rule. So I'm just going to pause. Thank you. So just quickly, what I've done is I've split this triangle up into two right angled triangles, and I've called one theta 1 and theta 2, and there's a relationship. They both share the same height. They both share this same height here, and we can say that SOHCAHTOA, the opposite, is the height of the triangle, and they do both have the same height. They don't share common values of theta, however. So what we've got then is actually it can be shown that A over B, if I think about it, like given that H is equal to, let's do the left-hand side, H is equal to A sine theta 1. I'm just rearranging this formula here. But over on the right-hand side, we've got H equals B sine theta 2. Shh. Can you see there that we do know that H is the same thing? I've got two equations. I've got equation 1, this is equation 1, and this is equation 2 over here. Now, what can you tell me? If those H's are the same, what can I do? I can let equation 1 equal equation 2. Hope you are following me now. So what we're going to do is we're going to let equation 1 be equal to equation 2 because they're both in terms of H, which we know are equal. All right, so I'm trying to prove this to you, and this is where it come from rather than just say, here's a formula, go and use it. Now, what can you say? Equation 1, we've got A sine theta 1. A sine theta 1 is equal to B sine theta 2. Now, A and B aren't the same, either are theta 1 and theta 2. Now, this is actually we're almost getting there. This is almost the SIne rule. What happens if I want to get A and B? What happens if I want to get A and B on the... Let's say that I'm going to get... I think we might get... Would I just sort of stop there? I just want to say that this is where the SIne rule comes from. Okay, that's probably looking a little bit similar to here. Thank you. Whilst you're talking, you're not listening. And unless you want to come up here and teach it yourself, listen up. Now, when we use the SIne rule, we've got to label the triangle. So this is a really important part. I'm going to pause it here and not have that on video. Paused it. Okay, now, let's have a look at this triangle. Now, first of all, what we're going to do is we're going to label it. We've got to label the vertex of the triangle A, B, C. So can you please do that now? We'll just draw this triangle out. This is a non-right-angled triangle. Now, once you draw A, B, C, and can I just rub this out and even say that it doesn't have to be A, B, C in that order? It can be, if you like, if you wanted to do it this way, you can say that this is A, this is B, and this is C. It is not that important. However, one thing I will say is you cannot go, shh. You have to be consistent with how you draw your triangles. Now, opposite to side A, opposite to this angle A in here, we actually have length little a. Okay, so this is the notation. So if you use A, B and C like so, then this has to be side little a. Opposite side big C, the angle big C is side little c. And if you're consistent with this approach, you won't go wrong. And across the road from angle B is little b. So note the terminology. The terminology we used, these here, the little lowercase notation, that is for the sides. Okay? And the uppercase, A, B and C, these are angles. Okay, so these things, C, if you like, these are the angles. So uppercase are angles. All right. So your triangle might look a little bit different. You might use a different value for big A and little b or whatever, but the main thing is that if little b, if you've decided to start your triangle here, A, we're going anti-clockwise in this case, B, C, as long as you use the opposite side to angle A as little a, then this rule's going to work. Yeah. Yeah, that's the rule. Yeah. Now that rule really just comes from rearranging this thing that we use there, because if I was to rub this out, both of these triangles have the same height, triangle 1 and triangle 2, and we pretty much use SOHCAHTOA of a right angle triangle and then rearrange those equations to get the SIne rule. That's really all where it comes from. So now we've got into how we do it, let's go ahead and do an example. All right? Importantly, a SIne rule can only be used when we have, in certain situations. There's actually what we call the cosine rule, which comes a little bit later. But what we need is if I have this length, I have the opposite angle. If I have this angle, I have the opposite length. In that case, if I've got like two angles and one length, then I can find the length of the side which is opposite to an angle. And there's another thing. If I've got I could have two lengths and one angle, and I can find the other angle. So what we're going to do is we're going to write out the SIne rule. But importantly, this is little a. So where do you think I'm going to put big A? 45 degrees. So I'm going to do that. Now if I've got big A over there, I'm just going to go around anti-clockwise, and I'm going to say that that's side B, that's angle B, and that's angle C. Do we give a hoot about what angle C is? No. We could. We know that the angle C, I could even tell you, what is angle C, Patrick? Angle C. What is angle... Angle C is a place sort of down the coast. But what is... Hey, that was a good one, wasn't it? What is angle C? Geometry, like geometrically, if you think about how many angles. Thank you, 75, thank you. You really do look like a Patrick. You should change your name to a Patrick Matthew. Thank you. You're off the hook, man. But 180 degrees in a triangle, yeah? Shh. All right. That's funny, angle C. So funny. All right. We don't give a hoot what angle C is. But we do. Let's write out what we like. So what does that mean? It means that the SIne rule still works, but we couldn't give a hoot about this part of the SIne rule because we don't care about angle C. We don't even know what side little c is. So forget about it. That's the thing with the SIne rule. You have to understand that you don't need all of it. You only use what you need to use. So in this case, let's write out what we know. Well, we know that little a on sine A is equal to little a on sine, or little b on sine B. So that's the SIne rule. And this is always the case for a non-right angled triangle. We can use it. We can even use it for a right angled triangle, but it's not worth it. So, little a on sine A. What is little a? We don't know what that is, but we do know that sine of A is the same as sine of 45 degrees. And that is equal to little b, which is, well, little b is opposite side b. So actually you'll have to label that as little b. This is side little c, and we know that that's side little a. So little b is 5.1, and little sine b is 60 degrees is that. Now, I could go ahead and if I had a CAS calculator, I could put that in and actually solve for my one unknown. And I could do that. I might even do that now. Because I want you guys to be able to use your CAS calculators, especially coming to next year.
Should this be in radian mode or degree?
Degree mode. That's right. Now, but at the same time, you guys should be able to do this. You guys should be able to do this because there's actually exact values. I'm going to do it in the calculator, but I'm going to just show you how I would do it. I want to solve for A, don't I? So what I want to do is I want to have A by itself. And if I have A by itself, then I can say that A is equal to, well, I want to multiply both sides by sine 45. Okay, because that's going to cancel those out. So I can then say that A is 5.1 times sine 45 degrees, and then it's all divided by sine of 60. So that's one way of doing it, and that's doing it by hand and without a calculator. 5.1 though, sine of 45, I did actually get you guys to draw up your table of values. Sine of 45 was actually 1 on root 2. There's an exact value for 45, 60 and 30. And I then have to divide all of that by sine of 60. And sine of 60 is root 3 over 2. Alright, so without using a calculator, I'm now going to change this divide symbol to a multiplication, which means I have to invert this guy over here. I'm going to flip that around. I'm going to change that now to a 2 over root 3. I'm going to change that to a multiply. Now I've got A is equal to 5.1 times 2, and root 2 times root 3 is root 6. So I've got, now you'd have to use your calculator, wouldn't you? Yeah. Yeah. That's correct, yeah. Could have, I'll resume. So what you could have done is if your algebra is not so good and you did have a CAS calculator, you could actually just do this thing here, and I could say that A on sine 45, and I can do solve. Now, of course, to do solve, what's the shortcut? Menu 3, 1. Menu 3, 1, go to solve. And I'm going to solve A, well, you know what I'm going to do? I'm going to get my little fractions button, and I'm going to solve A, ooh, whoops, A over, and be careful, my calculator is not in degree mode. So I have to be careful. I'm going to say A of sine of 45 and do a little pi button and degrees. A of sine 45, I'm solving, is equal to, what was B? 5.1? So I want to do control this 5.1 over sine of 60. Degrees, be careful. Trig sine of 60 degrees. All right, and be careful, what are we solving for? So we need to do comma A. And 17 root 6 on 10. Yeah, no, that's just giving you the exact value. 4.16. Is that right? Yeah. Good. So, I want you to know how to be able to, how to use your CAS calculator when appropriate. However, you could do it. 17 root 6 on 10 is basically that. We've got that. But that's simplified in a... Now, so we found what A is, and that's using the SIne rule. Now, let's have a go. Shh. Can I pause this video and get you to have a go at this one here, please? So if you're watching this at home, pause it and have a go at it. Where are we? Yo. All right, so just quickly, I'm going to stop the video here. I don't want it to go over 20 minutes. But you can see here that this is what you should have had. And we're going to solve for B. If you had a CAS calculator, I've been through an example where you could do it without rearranging. However, can I just say, we don't know the exact values to these. You're going to have to do it in the calculator. So if I rearrange this equation, I'm not going to do it, I can say that B is equal to 12.7 times sine of 63 degrees over sine of 85 degrees. And if you were to do that in your calculator, you can work it out yourself. I'm just going to stop the video now and I'll answer those questions now. All right.